You ready?
Yeah.
Okay. Not right now, just like in principle, are you ready? Danielle, I'm not ignoring your message. I'm just hoping I answer it in class today. Okay, you guys. I'm going to start off with a couple more Vim tips. Then I will let John do his thing. What's your topic today, John? IP addresses. Are we running out? Yes, we are. And then I will, once John is finished, I will get back up and talk about what the book calls multi-way branches. This is section 3.3, I think. And then we will talk about loops, and hopefully by the end of today, having seen enough of different examples of loops, you will be well prepared to do the hailstone sequence exercise. Any questions before I get going? Go ahead.
Were you going to discuss how to count each number in the
Yes, lots of different examples like that. Other questions? All right. Rachel.
On the program, you showed us what it, when you demonstrated it to us, you showed us what would happen if you said, yes, I want to see the numbers in the sequence. What do you want it to show if the user says no?
Just the number of terms in the sequence. Yep. Other questions? All right, here's another couple of minutes about VI. Let's see. Maybe I'll show 270 because I often deal with more than one file in 270. We'll do 167. So a lot of you may have gotten the comment on your homework, use a consistent indenting scheme. Let me show you how to very quickly use a consistent indenting scheme. Where do I want to go? Let's go here. And I won't show you the hailstone one. So here, what do I mean by consistent indenting? Everything between matching curly braces should be at the same level of indent. So in my case, all of the statements between in the main body are indented 2 characters. And then if I start another block, like a while loop or something, then that's further indented 2 characters, etc. And the deeper nesting your blocks go, the more indented you are. This is a standard technique for helping the programmer see what's part of a particular block. Because when you get a really large program and lots of nested blocks, it gets really difficult to figure out what belongs to what block. VI, the developers of VI recognize that this is an issue. And let me just take a couple out of place here, make this a little bit sloppy. In fact, I'll take this whole if statement and move it back. So now, if I got this, I would say use a consistent indenting scheme. All right, what I want you to do before you turn it into me, or even as you're programming, because again, this really does help, go into visual mode. So hit V, and then scroll down and essentially highlight the entire program, and then hit the equal sign. And that will fix everything. That's the auto format button. So it will auto indent whatever is highlighted at the moment. So again, you turn on the visual mode, you page down, you highlight the whole thing, and you hit equals, and that will filter everything through the formatter. All right. Yeah, and I know you're thinking, well, why didn't he tell me that 2 weeks ago? And the answer is you got to kind of pick and choose. There's so much in VI and Vim that if I just dumped it all on you the first day, it would get lost. I was going to show you something about buffers, but in this class, buffers aren't quite as important at the moment. what do I mean by a buffer? You can have more than one file open at a time in VI. I don't even have more than one file in here, but I could do something like vim star .cpp. So I can open up all of the C++ files in this directory, and there's only 2 of them, and I can switch between them. We'll talk more about that later when your programs start to occupy more than one file. That should start happening sometime around the middle of the semester. Your programs will start to be spread across typically 3 files. Any other Vim questions before I move on? Did I talk about FileZilla in here? Yeah. I did? Okay. So I just want to remind you that if you're having trouble uploading your programs via links, go ahead and grab those files, move them over to your computer using FileZilla, and then use the upload page on the class web page through Chrome or whatever. This tends to be a much easier system to use because it lets you browse for a particular file, pick it, and then upload it. John, let's do your thing.
All right.
Do you want the computer?
Yeah, that's good. Yeah.
Do you need to log in at all, or?
No, I just
just need a browser.
Google a picture.
Okay.
That's about it. Go ahead.
All right, so I'm talking about IP address depletion and whether we're running out, which we are. Oh, that's not what I wanted.
Show my text to my daughter.
Oops.
This is why I mute the screen. Now you're searching. Okay.
Sorry. So this is how IP addresses are usually formatted, ones and zeros, and this is the current system of IP addresses that we currently use, which is IPv4, and it allows for approximately 4.294 billion IP addresses, which seemed like a lot in the 70s, but is no longer a ton. And we are currently running out of IP addresses. Some areas have run out. Each device that connects to the internet needs to have an IP address attached to it. There are 5 regional registries underneath the that allocate IP addresses, and I believe Europe just recently ran out. There are ways that you can reallocate. I couldn't quite figure out the system that they were talking about when I looked into it, but it appears that there are ways you can reallocate IP addresses to allow for a little bit more room. But essentially what needs to happen sometime in the future is a switch from IPv4 to IPv6. And IPv6 would allow for 3.4 times 10 to the 38th IP addresses. Once again, you can look at this and imagine what IPv4 would look like. It would be significantly bigger than this, and exponential growth is great. The problem is most devices are not formatted for IPv6. And many websites, not only do you need devices that are formatted for IPv6, you need websites to format for that. And many websites have thought about this. Facebook a few years ago tried to do this. If you type in and you're under a v6 enabled device, which 99% of computers right now are not, you will get an error message and it will not allow you to go there. But if your device is enabled with IPv6 technology, you can access that website. So the switch will involve both websites changing to be IPv6 compatible and devices becoming IPv6 compatible, which isn't incredibly different on a micro level, but it will mean that eventually everybody will need to switch. So given how valuable the internet is to us, it's a pretty small price to pay. And it's similar to what happened, I'm not quite sure how long ago it was, but when phone numbers switched from 7 digits to 10 digits, this is sort of a similar thing happening with the internet. So yeah, that's IPv4 depletion and the switch to IPv6. So yeah.
Question. Go ahead.
So is the change going to require, besides just the websites moving to V6, is it a hardware change on people's computer, or is it like a software?
It's a software change.
Actually, there are places where it's hardware changes.
Oh. Well, then maybe.
Some of the, essentially IPv4 is 4 bytes, and a lot of, especially really fast routers have hardware handling capabilities that only take in 4 bytes and deal with them. So, other question?
How soon is this really going to be like a super serious issue?
It's starting to be a serious issue. Like I said, there are things that can be done to mitigate without switching to IPv6. So probably within the next few years, the switch will need to be made. I found a few different timetables. From what I found, it was a bit hard to estimate how long it would take to really run out and how long it would take to make the switch to IPv6.
A lot of businesses are already dealing with this. For example, Whitman College deals with this using what's called network address translation. So when you're connected to the internet, for example, my computer's connected to the internet right now, and it's using a whole collection of numbers that only work inside Whitman College. So for example, there's maybe 10.1.33.54 on that computer. That number will only work inside my network, inside Whitman's network, and there may well be a 10.33.1.54 inside of IBM somewhere attached to some computer there. And what happens is that they stay inside the corporate network in a sense, and they don't clash with the same number that's inside some other protected corporate network. So that's one way of conserving address space. And then if I have to go outside of the network, then I do need an actual honest-to-goodness IP address. But what happens is that machine might be sharing an IP address with that laptop right there. And there's a computer at the border that figures out which traffic is supposed to go to that machine and which traffic is supposed to go to that machine. There's a lot of, that's called network address translation.
I have a question for that.
Yeah.
So sometimes when I'm in my house and I have issues with the internet router, it says the same IP address is using this, whatchamacallit, is that because of what you just
Yeah, and you can't have it inside the network.
Interesting.
So if there are two machines trying to use the same IP address, it's like two different houses trying to have the same phone number. It just doesn't work.
Yes.
Why can't we, what's wrong with backwards compatibility? Why can't half the internet be the old ones and then half of them be the new ones?
Because some devices are compatible with both IPv4 and IPv6. Although in an ideal world, once the switch has been made, all devices would only need to be compatible with IPv6. I'm not sure exactly what the problem is with half compatibility, besides just streamlining the process. I think in some ways that's what we're getting to at this point.
Backwards compatibility is not so much a problem as forward compatibility. So as I was mentioning with the Cisco router maybe having just 4 bytes for IP addresses, there's no way to force that thing to do 6 bytes, or however many bytes it is, I don't know, for IPv6. So I think it's forward compatibility that's the real problem, the old hardware talking to the new.
Oh, I was more thinking about websites switching over. like we could just have new websites in IPv6 come out.
Yeah, I don't know as much about this as I should. So.
Just
yeah, it's a good question. Okay, okay,
One more question?
and then we're done.
So, is it true that IP addresses are provided by the internet provider? And if so, how is it possible to have a static IP address?
Wait, what was the last bit?
Well, it's my understanding that IP addresses are provided by the internet provider.
Yeah.
And if that's true, then how can people have static IP or dynamic IP addresses, that like constantly change?
It is true that it's provided. I wrote this down. IP addresses are assigned by the Internet Assigned Numbers Authority, like with the 5 regional boards that I talked about. I'm not sure about the second part of your question, actually.
When you turn on your cable router or something like that, and it makes a connection to the cable company or to the phone company, they have a bank of real, honest-to-goodness IP addresses that they then dynamically assign to that router, and that's your public face. And then behind the router, we're using network address translation, just like I described earlier. So everybody that's connected to the internet at home has one real, actual IP address. The problem is you turn the router off, you turn it back on, you might get a different IP address. So that's called dynamically assigned IP.
So is there such a thing as like the router constantly like making the computer be under a different IP address while it's being used?
Typically not, but the router will every couple of weeks or maybe even every couple of days will flush out the old IP address and bring in a new one. I think we have to stop.
Yeah.
But yes, thank you.
I was tepid clapping. All right. Let's talk about more complicated if statements, and when you should just use a bunch of if statements, and when you should use if else. So let me pull up my notepad here, and let's talk about what the book calls multi-way branching. So the idea is you have some thread in your program that's coming down, and it gets to a point, and then it wants to go this way, or maybe this way, or this way, or this way, depending on some collection of Boolean expressions. So this is a multi-branch. And the syntax for this, oh, come on. Really? All right, well, I'll do it the hard way. The main syntax for this is using if statements, so collections of if statements. Okay, I want to show you why is that being so. That's really weird. Never had it fail like that before. All right, well, we'll see what happens when I get to the bottom of the page. I may not be able to scroll up. Collections of if-else statements. So there are kind of 2 ways of doing this. You can do if. Boy, we're just having a. Here, I'm quitting this, starting over again. Full page. Nope. Anybody do OneNote well enough to know what's happening here? Usually when I touch it, it just slides forward.
I think sometimes on your laptop, there's like when you touch the pad, it'll click. You turn that off.
Are you saying?
Go to draw. I look at hit draw.
Yeah.
So.
Oh, panning hand. Yes. Thank you, Emily. Okay. So here, let me sketch an if statement. This is an if statement from my data structures class, but it doesn't really matter that it's from data structures. I'm almost settled down now. If the number of items is equal to 0, then we are going to add an item to the list. And we're going to adjust, and you don't have to know what this is, the head pointer. Okay, so there's an if statement. Well, let's go back up here now that I know what I'm doing. Or do I? That is so bizarre. It's panning now. It's not a good day. I might have to use chalk today. Okay, I think I'm going to use chalk today. Oh, I know what I could do. Okay, so if the number of items is equal to, say, 0, oops, then what we're going to do is add the item to the list, and we're going to adjust something mysteriously called the head pointer. Okay, if the number of items, and we're also going to increment the number of items, so num items plus plus, like that. Okay, if the number of items is greater than 0 and the number of items is less than the capacity, then we're going to add the item to the list. And that's it. And then we'll increment the number of items. And if the number of items is greater than or equal to capacity, then we are going to reallocate the list, add the item, and increment the number of items. And this is a sequence of if statements that you might see in a data structures class where you're populating a list of items for some purpose. There's a problem with this, the way it's written right now. The intention here, if the intention is that one and only one of these guys then there's a problem. What is that problem? So if the intention is that one and only one of these blocks is to be executed, then there's a problem. What is it? Well, and you might think that it wouldn't fulfill multiple things because either the number of items is equal to 0, or the number of items is greater than 0 and less than capacity, or the number of items is greater than or equal to capacity, right? Those are mutually exclusive conditions, right? What's wrong? Well, let's pretend I defined a starting value. I'm leaving a lot out of this thing, but let's pretend we start at 0 or something like that. Although that's not really, let's just pretend it has a value in it.
Multiple if statements, like going, because part of each other, so it can hit the first one. If it's 0, it can hit the first one, become 1, and then hit the second one.
Exactly. Does everybody see that? The problem with these 3 branches is you're actually adjusting the thing that later if statements are using to make decisions. So for example, it comes in, and let's pretend it comes in and it's 0, so it's going to go and do this. But one of the things that it does is this, which turns it into 1, which then you get to here, and it says, is 1 greater than 0? And is it less than capacity? Probably less than capacity. Then it's going to do that one and increment that. So in fact, these 2 guys will get executed, and that was not our intention. Of course, this is something that you may really actually want to do in a program. How do you fix this?
If else.
You use else. So else here removes, and then we could put even another else. It doesn't really matter. Or we could remove this third condition. In fact, let me leave that alone here, and let me just copy this and show you. So to guarantee that one and only one branch is executed, use else's. I don't know if there needs to be an apostrophe there or not. All right. So then you would say, if the number of items is equal to 0, yada, 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 else, if the number of items is greater than 0 and the number of items is less than capacity, do that, else, do that. Now let's think about how this works as opposed to the earlier multi-way branch. Let's pretend we come in and the number of items is 0. You're going to do this block, right? And then when you get to the end, where do you go? You go all the way down to here. Because how does an if-else work? If this is true, you do the top block. Otherwise, you do the bottom block. The bottom block, the bottom part of this if statement is everything from the if down to this num items plus plus plus. So if the number of items is equal to 0, it'll do this block, and it'll skip everything from this else down to the end. Okay, let's pretend that the number of items is 1. So we come here and we check and we see that number of items is not equal to 0, which means we do the else statement. The else statement is to then execute essentially a second if statement. Now the second if statement says, well, is 1 greater than 0? Yes. Is 1 less than capacity? Yes. So we're going to do this. And what about this? Skip it, because it's just another branch on an if-else. So this, and you can string together as many of these if-else's as you want and get essentially one and only one of the blocks to execute. That's the big difference. That's the takeaway for today for multi-way branches. Sometimes you may want more than one branch to occur, in which case you do a very carefully constructed sequence of if statements like this. And sometimes you would build a collection of if statements where you weren't tweaking the things that later statements depended on, in which case that would also be perfectly safe, possibly safe. All right, any questions about that? The book, I didn't do this nearly the justice that the book does, so again, I encourage you to read the section. The book also talks about another structure called a switch statement. I don't use switches in this class very often, but it's certainly good to know that they're there and how they work, so I encourage you to read that. If you want to use a switch in some circumstance later in the class, that's great. It's just another way to do some stuff that you can do with if statements. And that's true in C++ in general. There are lots of different ways to do the same thing. We're actually going to see that when we start talking about loops in about 5 seconds. Any questions? All right, let's talk about loops. And I want to move to the in-class example section here. Wow, I didn't remember this guy being here. Did I do this? Yeah, that was a simple loop. I remember that one now. All right, let's do a complicated loop. So the goal here is to show you, last time I showed you the simple while loop. How does a while loop work? Remind me. While something is true, keep doing it. One of the things that you can really easily run into with a while loop, a problematic thing that you can run into, is if you don't set your loop up right, it'll run forever. Has anybody had that happen to them? Yeah. Does anybody know how to get out of that? Yeah. I apologize for not sharing with you how to get out of that. You do not have to, close down the window. Let me show you an infinite loop here. So what if you're really silly here and you do int I equals 0, and then you do while I is greater than or equal to 0, I plus plus, and maybe C out I. So this is an infinite loop, right? Because that condition, I start out at 0, which is true, and then I increment. It only gets bigger. So this loop condition will never go false. Compiles just fine, because the compiler is not going to figure that out for you.
That's horrifying.
Yeah, it's just counting as fast as it can, the poor thing. How do you get out of this? You hit Control-C. Hold down the Control key, hit C. And yeah, I'd forgotten that you guys had to deal with a loop in the quadratic equation solver, checking for A equals 0. And there were probably a few of you that ran into infinite loops at that point. Some of you early birds that are working on the Hailstone sequence may have run into it already as well. So you don't have to shut down the terminal. Just hold down the Control key and hit C. Do Macs have Control keys?
Yeah.
They do? Okay. So I can't guarantee that that's the case for a Mac. There might be some other weird key combination. But Control-C on a Windows machine. And it counts pretty fast. It got up to 983,000 in just the time that I was talking. Let's do some more interesting stuff with loops rather than infinite loops, which are actually infinite loops are useful, believe it or not, but not right now. How about we write a while loop that collects characters from the keyboard and puts them in a string until I hit a period. And then when I hit a period, it'll print out my whole string. Let's try that. So call it character collector. You may have read about strings. You should have read about strings earlier. So if you want to use a string, what's a string? Oh, come on. Danielle?
A bunch of characters.
Yeah, it's just a collection of characters in a particular order. Really handy for representing words and sentences and phrases and so forth. If you want to use a string variable in C++, you have to include the string library at the top. And then to declare it, just call it string A. So at this point, that's just an empty string. And we'll do the following. And let's get a character as well. Call it R. While R not equal to period, we're going to collect characters and add them to a string. And I guess I should start by making sure that the character is not the period character. So I'll just set it equal to 0. Okay, cout, enter a character, and then I'll say period to stop. And then we'll read in that character, whatever I happen to type in, and then I'll add it to the string. And then when I'm done, so at some point I hit the period character and the loop stops, I'm going to print out the string. Let me show you first that this works, and then we'll talk about some of the reasons why. So enter character, period to stop. How about, oops, I misspelled it. So there's the collection. Let me try it again. It's hard to type one character at a time like that. Oh, come on. Something must be happening on my computer. I'm going to move that out of the way. Oh, there we go. So let me see if I can do this. W, H, I, T, M, A, N. And then period to stop. And there's the collection. All right, let's see what's going on here. So I essentially I have a while loop that runs over and over and over again. It asks for a character, it reads a character, and then it tacks the character onto the string. Again, since we haven't really worked with strings, and at best you've read about them in the book, you may not be aware of this, but if I take a string and I add a character to it, that's actually well defined in C++. It'll take the character and tack it onto the end of the existing string. So it starts out with an empty string and adds the first letter W, and then it goes back around and gets the H and adds that onto the end right next to the W, and then the I right next to the H, and so on. It doesn't show me anything other than it adds it on, goes back around. If the character was not a period, then it's going to do it again. If it is a period, it's going to add it, it's going to come back around here, and then period does equal period. So the loop stops, and then I print out the result, and the result, all of the characters are sitting in this single variable A, this string variable A. All right? Let's do something else. Any questions about that one? Emily?
How come we chose R equals 0? Does that just mean it's empty?
I happen to know that when you set a character equal to 0, that's not ever going to be an actual character. Okay. If you look at the ASCII table, it's the null character.
Can I sort of ask a variation of the question that I emailed you? So if you wanted to stop it when it was like a period or a comma, how would we?
All right. Suggestions, people. Okay, so we could do 2 vertical bars. That's the character that's above the backslash key. Now what? What'd you say, comma?
Yeah. So will it get mad at you if you have, I had like friends, and then I had like friends and friends?
You should be fine putting as many parentheses around this thing as you want. This is certainly legit. And you could even go one step further if you really wanted to. So that should be okay too. If you're still having trouble, just show it to me and I'll see if I can figure it out. Okay? So that's what you tried to do, Danielle? Yes? No? She's moved on. All right. There. I'll leave that in there. Let's do a loop that counts. That was one of the questions that we had earlier. We want a counter. So let's do a loop that counts. While let's do while, we'll do the same thing. R not equal to a period. And this time I'm just going to count how many characters I type. So character R, we'll set it equal to 0. Cout, enter a character. CNR and I++. And then cout So this is just going to ask for characters. I'll type them until I get tired. Then I'll hit a period. And I'll get a report about how many characters I typed. So it's right. This is a really standard approach to counting. You initialize the variable. It's really important that you initialize it. If I don't initialize it, I risk getting just junk. Let me run this again. I may not get junk, unfortunately. These kinds of things are unreliable. Yeah. If you don't initialize it, you risk using whatever happened to be in that little memory location the last time it was used. A lot of times there's nothing in the memory location, so it actually starts out at 0 anyway. But just to make sure, make sure that you initialize the counter to some appropriate value, because otherwise it could be random. Questions about this one? Yeah?
Is there a way to stop it without putting the period? Because then it counts the period, or would you just type in you entered I-1 if you didn't want that?
Sure. So this leads me, I didn't even pay him for this. This leads me to the next piece of while loop syntax. If R equals period, break. And what that will do is stop that loop right there dead in its tracks, even before it does the I++. And it will exit the loop and pick up right here. So let's see if that ignores the period. Yeah, we could do 1, 2, 3, period. Okay? Good question. So a way to short circuit a loop at any time is with the break statement, and the break statement will break out of the innermost matching curly braces. So if you have two loops, one inside of another, and you issue a break statement on the inside loop, it'll only break out of the inside loop. The outside loop will keep going. All right. Loops are really good for generating sequences. A famous sequence is the Fibonacci sequence. Let me show you how to generate that one. Has anybody heard of that one, ish? Yeah, so the Fibonacci sequence, the way it works is, I don't want to go back to that thing. Well, I'll just show you in the program. So now we're heading towards some territory that should help you with your program. So the Fibonacci sequence starts with two seed values, n0, I'll just call it n0. N0 is 1, and n1 is 1. And then nk plus 1, actually nk plus 2, is equal to n k plus 1 plus n k. For example, when k equals 0. So when k is equal to 0, what you have is n2 equals n1 plus n0. Does everybody see that? What's n0? 1 and n1? 1. So that's 2. So what we've just learned is that n2 is actually 2. Let's do n3. All right, what's n2? And n1? So n3 is 3. You might think, oh, nk must be k. Not true. Let's try n4. Okay, n3 is 3, n2 is 2, n4 is 5. And that's the beginning of the famous sequence, 1, 1, 2, 3, 5, 8. Okay? 13, yeah. 8 plus 13, 21, and so on. Just keeps going that way. This is a sequence that comes up surprisingly often in natural phenomena. Really remarkable sequence, and has been heavily studied by mathematicians for centuries. And it still yields interesting results. Can we generate, say, the first 10 terms of the Fibonacci sequence using a computer program? The answer is yes, and the way to do that is with a loop. So let's talk about how we might do this. We need a few variables. In particular, we need three variables to generate this equation. We need the two variables on the right-hand side and then a variable on the left-hand side to hold the result. So let's get those three variables. We'll say int n0, n1, and we'll just call it n. And we know that n0 is equal to 1 and n1 is equal to 1. No, these are assignments. So we know that that's how the Fibonacci sequence starts out. n0 is 1, n1 is 1. How do we generate subsequent versions of the sequence? Or subsequent terms of the sequence, excuse me. Well, I said we were going to ask for 10 terms. So let's get a variable, call it num terms equals 0. And we'll say while, and let's get a counter also. Let's ask the user how many terms they'd like to see in the sequence. Okay, so we ask how many terms we'd like to see, and we get number of terms from the user. Let's start a while loop. While, and we'll just start off simple. While count is less than num terms, we want to generate the next term in the sequence. So how do you generate the next term in the sequence? Well, you add the previous two terms, n1 plus n0. So that's the next term in the sequence. Everybody agree with that? And what we'd like to do is print that out. We want to show that to the user, so we'll do cout n, and maybe we'll put a comma in there just to separate it from the next term that's coming. So we've computed the next term. Now we want to loop. So we do count. We want to say, oh, well, we've found one term, so we're going to increment the counter to indicate that we found one term. And that's really important because the only way that this loop is going to stop is if this number gets to be as big as that number. So if you forget to increment the counter, the loop's going to go forever. Here's the tricky part. The way this works now, to compute the next term, n0 becomes n1, right? Sorry, n1 becomes n0, and n becomes n1. So even though we're generating a sequence of indefinite length, we only need 3 variables to do that. We set the first 2 variables, we compute the third, and then we slide them over. And then we compute the next one and slide it over, and compute the next one and slide it over. That's all that's going on there. And we can very efficiently do this with 3 variables, just constantly trading values. Let's see what this looks like. So I get to see 3 terms after the first 2. I don't have time right now, but I could tweak it, right? I can just adjust these numbers so that it shows me 1, 1, and then 2, 3, 5. How would I get 1, 1 out of this? Yeah, I could just do that at the beginning, right? If num terms is greater than 0, cout 1. Oops. And if number of terms is greater than 1, we'll print out 1. And 3 is still not quite right. We have to do some tweaking now to make sure that we're showing the right number of terms. But if I punch in, say, 0, I don't get anything. And if I punch in 1, well, I've got to work on that. But yeah, so there's an off by 1 error that we'll talk about on Friday. So when you're dealing with loops, you have to be careful about, just getting it just right. You have to test. Hopefully I'll figure out what's wrong with my note-taking thing.